Hi, I'm Bob Pryor. Today I'm talking to you about radian measures. One way to define a radian is as the length of the radius of a circle. And as you know, the circumference of a circle is 2 pi r in general. But if we have a unit circle, the radius is 1. 1 what, you might ask? 1 radian. That's right. So when we multiply this, we get 2 pi radians. We might abbreviate that as 2 pi rad for radians, or we'll use 2 pi r, with the r kind of where the degree symbol might be for an angle. And this is the circumference of a unit circle, 2 pi. So let's take a look at the full circle and recognize that if we call the circumference 2 pi is equal to 360 degrees, then we can find other radian measures around the unit circle by doing some division and multiplication. Here I am dividing by 2, and it shows that pi radians is the same location as 180 degrees. If we divide by 2 again, well, now we have pi over 2. That doesn't simplify. Pi over 2 equals 90 degrees. Oh yes, pi over 2 radians equals 90 degrees. And from there, we can find other measures. For example, we can multiply each side by 3, and that becomes 3 pi over 2. That's how we read it. 3 pi over 2 radians equals 270 degrees. 3 pi over 2. By the way, I'm going to be going pretty quickly through this video, so if you ever need to pause or rewind, feel free to do so if I go too quickly. Here we have what we just learned about pi radians is equal to 180 degrees. And as an equation, we can divide each side by pi radians to discover that 1 equals 180 degrees over pi radians. We can use this as a conversion multiplier between degrees and radians. Another option, we're doing this same setup, but this time we're dividing by 180 degrees, and that gives us a different ratio for converting between radians and degrees. Which one should we use? Well, that all depends upon what we're given and what we're asked for. Here we're asked to find the equivalent of 72 degrees in radians. So I'm going to start by writing that as 72 DEG for degrees, and I'm going to make it into a fraction because I want to multiply by one of those conversion fractions, conversion ratios, and I want to divide out the degrees, which is 180 degrees in the denominator and pi radians on top. You see how the degrees cancel? Yeah, then we no longer have degrees, we just have radians. 72 pi radians over 180, I'm going to divide each of those by 9. And that gets us 8 pi radians over 20. Oh, we'll divide by 4, can take it down a little bit further, and that becomes 2 pi over 5 radians. And that's the equivalent of 72 degrees. This time we ask the question, what is the degree equivalent of 11 pi over 18 radians? You can see how we want to divide by the radians, to divide out radians. And so it's the multiplier 180 degrees over pi radians, and they do indeed cancel out. Boy, I'm going pretty quickly there. Let's see what else cancels. Oh, the pi's cancel, good. And 18 into 180, that becomes a 1 and a 10. Looks like we're left with 11 over 1 times 10 degrees. Okay, that's 110 degrees. So that's the degree equivalent of 11 pi over 18 radians. Now let's find the radian equivalent of degrees in the first quadrant. I'm talking about 30, 45, and 60 degree angles. We're going to start with what we already know, that pi is equal to 180 degrees. And we can divide each side by 3 to find out that 60 degrees is now equivalent to pi over 3 radians. Notice I'm not using the r for radians anymore. We just know that if it's pi, it's got to be radians. We can take those same measures and multiply each by 1/2, and that tells us that 30 degrees is pi over 6. So right at 30 degrees is the very same location that pi over 6 resides on the unit circle. Let's now take the fact that 90 degrees is the same as pi over 2 and multiply each side by 1/2. That'll give us 45 degrees equals pi over 4 radians, or just pi over 4. So now we have a radian measure for all of the angle measures in quadrant 1. Okay, so let's use this information, the fact that pi over 6 equals 30 degrees, to actually count by pi over 6 on the unit circle. Let me start by locating every 30-degree measure after 0. We can see them listed here in order around the unit circle, including all the quadrants and all the axial points. And we end at 360 degrees. But we're going to count this way. Every 30 will count 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. And even when we get to pi, we're going to call it 6 pi over 6. And then 7 pi over 6. You get the idea, 8 pi over 6. You don't need me to say them each and every time. But this is how we can count by pi over 6. Now you'll notice that some of these fractions can be simplified. Like 2 pi over 6 can be simplified to pi over 3. And 3 pi over 6 is pi over 2. Now, you'll notice that when we get to 5 pi over 6, we didn't simplify. We just simplified at 6 pi over 6 and got pi. And you can see the others being simplified around the unit circle. In fact, 12 pi over 6 is 2 pi. But I'm going to circle the ones that did not simplify at all. And you'll notice something about their locations. They are located at the 30-degree related angles, where theta hat is 30 degrees. That means that all of these radian measures are equivalent or related to each other. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And notice we're talking only about the simplified radian measures. If they're not yet simplified, we can't say that they're related to pi over 6. But we can even take this further and much beyond 12 pi over 6 into 17 pi over 6, or make it negative, like negative 13 pi over 6. All of these are related to 30 degrees. Now let's take a look at the pi over 6 related angles around the unit circle. What we're going to do, though, is look at pi and 2 pi, not as they are, but instead as sixths. So pi is 6 pi over 6, and 2 pi is 12 pi over 6. Let's kind of think about what's happening here. Of course, 1 pi over 6 is in the first quadrant. But 5 pi over 6 can be thought of as 5/6 pi. 5/6, that's less than 1. And that means that 5/6 pi is a little bit less than pi. 7 pi over 6 is 7/6 pi, which is more than 1. So this value here is a little bit more than pi, a little bit beyond 180 degrees. And for the 11 pi over 6, 11/6 pi is a little bit less than the 12 pi over 6. It's almost 2 pi, not quite, and so it resides in quadrant 4. Let's do the same thing, first of all, with pi over 4 by counting around the unit circle. This time we're going to do every 45 degrees. You can see them listed here in order. 315 degrees and 360 degrees. And then we'll count again by pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4. And again, pi is 4 pi over 4. And we'll do the same thing. Notice 8 pi over 4 at 360 degrees. We'll simplify wherever we can. Pi over 2, pi at 270 degrees, 3 pi over 2, and yes, 2 pi at 360 degrees. But look at the ones that were not simplified at all. They are all at the same location in different quadrants, all related to 45 degrees. And that means that they're related to each other. So we see pi over 4. Basically, anytime you have a radian measure that's simplified with a denominator of 4, it's going to be similar to all the other ones with 4, including pi over 4, and you can go beyond. 15 pi over 4 could be negative. Could be like negative, well, wait for it, here it comes, 9 pi over 4. There it is. These are all related to 45 degrees. We're again going to look at the unit circle, and this time we're going to compare everything to fourths over 4. So pi, 180 degrees, is 4 pi over 4, and 2 pi is now 8 pi over 4, just for this demonstration here. 3/4 pi, 3 pi over 4, 3/4 pi is less than 1 pi, so it's in quadrant 2. 5/4 pi, 5 pi over 4, a little bit more than 1 pi, it's in quadrant 3. And right below 8 pi over 4, a little bit less than that, is 7 pi over 4. That means it's in quadrant 4. It's a little bit less than 2 pi. It's only 7/4, not quite 2. So that'll help you. This idea will help you locate these in the unit circle. Let's just spend some time with the pi over 3. Notice we're including every 60 degrees this time. And we'll count again, starting with 1 pi over 3 in quadrant 1, but then 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, almost, well, and then 6 pi over 3, yeah. And the ones we can simplify are only the pi and the 2 pi. So all the others are related to each other. All of them over 3, and of course you can see their degree measures. They all are related to 60 degrees. And just like 30 degrees and 45 degrees, if you have a simplified radian measure, this time with a denominator of 3, it's going to be related to each other. Here we have, I think, 100 pi over 3. You know, doesn't matter how extreme it is, it's still going to be related to pi over 3. And negative 20 pi over 3, same thing, all related to pi over 3. All of them are related to 60 degrees, so theta hat equals 60 degrees. And again, we can look at pi sometimes being 3 pi over 3, or 3/3 pi. That allows us to think about the unit circle in terms of thirds. 2 pi is 6 pi over 3. Of course, in quadrant 1, we have 1 pi over 3. In quadrant 2, it's 2 pi over 3, or 2/3 pi. Close to 3/3, but not quite. So that means it's in quadrant 2. It's a little bit less than 1 pi. And the 4/3 pi is 4 pi over 3, or 4/3 pi. It's a little bit more than 1 pi. It's in quadrant 3. And the 5/3 pi, we can think of that as almost 6/3, but not quite. So it's almost 2 pi, but not quite. So it resides in quadrant 4. It's going to be important for us to be able to locate these values in the unit circle. So here we have some numbers, some radian values, but we can't really indicate what they are until they are simplified. So 8 pi over 6 is not related to 6 or pi over 6, but it's related to pi over 3 because we simplify it first. And 75 pi over 60, you see, is actually related to pi over 4 after it's being simplified. Again, related to pi over 4. Negative 9 pi over 4 is related to pi over 4. And the last one, when we divide by 3, we'll see that this is related to pi over 6. It's 11 pi over 6, related to 1 pi over 6. Okay, sometimes we have radian measures that are actually greater than 2 pi, and that's when we want to use the, in this case in terms of 6 pi over 6, and 12 pi over 6. That'll help us locate 13 pi over 6 and the others. 13, of course, is more than 12 pi over 6, so we subtract away 12 pi over 6 and get just pi over 6. That's a first quadrant value. So 13 pi over 6, you can see over here, is in quadrant 1 at the pi over 6 location. 17 pi over 6, again, we can subtract away 12 pi over 6. And this time we get 5 pi over 6. But think about it, 5/6 is a little bit less than 6/6. So it's in quadrant 2 at the 30-degree location. And that's where 17 pi over 6 is, in quadrant 2. Now, if we need to, 25 pi over 6 is actually kind of another full turn around the unit circle. And so after 12 pi over 6, we go one more. Now it's 24 pi over 6, another 12. And so 25 pi over 6 can subtract 24 pi over 6. It also is located in quadrant 1, same location as pi over 6. Now for 23 pi over 6, instead of subtracting, let's think about it. It is actually 1 pi over 6 less than the 24 pi over 6. It's like 130 degrees less than 360. So it's in quadrant 4. Let's do the same thing with pi over 4. Again, but this time we'll think of radian measures with the denominator 4. 9 pi over 4, we subtract 8 pi over 4, we get 1 pi over 4, and that's at the 45-degree mark in quadrant 1. This is 3 pi over 4, that's in quadrant 2, it's 3/4 pi, it's not quite 4/4, so that's in quadrant 2. Now the 15 pi over 4 is actually close to 16 pi over 4. You can see on the right-hand side, that's the same location at 360 degrees. And it's just 1 pi over 4 less than the 16 pi over 4. So that's going to just be 45 degrees down in quadrant 4. And the 19 pi over 4 will subtract away that 16 to get 3 pi over 4. And again, that's in quadrant 2, just like the 11 pi over 4. Same location. Coterminal, if you will. And the same thing with pi over 3. But this time, of course, the denominators will all be 3's. So 8 pi over 3, we subtract away 6 pi over 3. We can do that mentally if we're able to, or just show it on paper. Either way, it's fine. Then 2/3 pi is in quadrant 2. It's 60 degrees equivalent in quadrant 2. 5 pi over 3, 5/3 is in quadrant 4. It's not quite 6/3. So it is the same place as 5 pi over 3 in quadrant 4. Same location. Here we can go and treat that as 12 pi over 3, the second time around the unit circle. And our location this time is 4 pi over 3. 4/3, a little bit more than 3/3. Will be in quadrant 3 at the 60-degree location. All right, well, so we're talking about angle measures now and radian measures both on the unit circle. And so just like the sine of 30 degrees is the y value, 1/2,